In this video, we're going to start doing some arithmetic with polynomial expressions, and we're going to look at combining like terms and multiplying. It's just a review before we work our way eventually into solving quadratics. Looking here at this first term, so we just want to simplify an expression. Now, when you're given an expression like this and you see things written inside of parentheses and an operation here in the middle, we want to rewrite everything without parentheses. If I have a plus sign in between these two terms, you can simply just drop the parentheses because technically there's a positive 1 out here, and multiplying terms by a positive 1 does not change its value. So I'm going to rewrite everything without parentheses. So I have 8v squared plus v to the third power plus 3v squared minus 2v squared. Now we look and we're going to go combine like terms. So I'm going to put all of my v squareds together and combine them to see how many I have in total. And so in total we have 9v squareds in total. And then lastly, we have that v to the third power. There's nothing to combine it with, so we're simply going to say plus v to the third power. Now, we combine like terms, simplify. If you ever see something tell you to write it in standard form usually has the highest exponent first. So we could write this as v to the third power plus 9v squared. Both are correct, but if they say to write it in standard form, biggest exponent's got to go first. All right, looking here at this second one. So this one is similar. The main difference is this time I'm subtracting two terms, or two binomials in this case. And so if I have a minus sign in between, when you start rewriting, I can rewrite the first one without the parentheses because there's technically a positive 1 here in front, which has no effect on the value of the inside. But this negative sign, I have to distribute it to everything. So that make minus 1, and then I got to distribute it to that 7x, so minus 7x. And then we go through and we combine like terms. So let's combine our x's first. So 3x and negative 7x makes negative 4x's. And then I have positive 2 and a negative 1 to put together. That leaves me with a positive 1. So we combine like terms, and that's what we get. All right, now I'm just going to increase the level of difficulty here. And so now I have two trinomials. Trinomial meaning tri is 3, so I got 3 terms in each of these that I want to put things together. Let's try to write things without parentheses. So if there's nothing in front, or if I have a plus sign in front, I can just remove the parentheses so that way I can combine like terms. So I rewrite without parentheses. And now that everything is outside of parentheses, I look to combine like terms. Start with the highest exponent. So the biggest exponent I see is x to the 4th power. I'm going to combine all of the x to the 4th. So I have 8 and I have negative 4. Combine that, we get positive 4x to the 4th. Then move to your next highest exponent, which in this case would be x to the 3rd. We're scanning our problem. There's not another x to the 3rd, so I'm just going to write plus 6x to the 3rd power. And then we go to our next highest exponent, which would be x squared. I have 3x squared, and then I have negative 4x squared. We combine those, that makes negative 1x squared. And then we have minus 2 on the end that I don't have anything to put with. There's our simplified form. Next one, this time we have two trinomials, but we're subtracting in between here. So we need to write everything without parentheses. There's nothing in front of this first set of parentheses. There's technically a 1 there. It has no effect, so I can take all of the stuff out of the first set of parentheses. I don't need to change any signs. And then we need to take everything out of the second set because I'm subtracting. I have to distribute the minus. So we'd have minus 2p to the 3rd, and then minus negative, so that makes plus 6p to the 4th, and then minus that positive, so I need to change that sign to minus 2p squared. Now that everything's outside of parentheses, we're going to combine like terms. Start with our biggest exponent, which is p to the 4th. I have 6 and negative 2. Put that together, that makes positive 4p to the 4th. Then we go to our next highest exponent, which looks like it's going to be p to the 3rd. Combine those terms. So negative 5p to the 3rd combined with negative 2 makes negative 7p to the 3rd. And then our next highest exponent is p squared. So I have 3p squared and then a negative 2p squared. That's going to leave me with positive 1p squared. And then there's my final answer because nothing else is considered like terms. Okay, now we're going to multiply binomials together. So we're going to apply our properties of exponents learned in the earlier unit, and then after you multiply, you look to see if there's any like terms to combine. So here in this first problem, we got 2x times 8x plus 2. I want to take the 2x because it's written next to the parenthesis. There's no operation symbol here. That means multiply. So I got to multiply the 2x to everything inside of there. 2x times 8x. Well, 2 times 8 is 16. X times x makes x squared. And then I need to multiply the 2x to the 2. So I'm distributing here. 2 times 2x makes positive 4x. And x squared and the x to the 1 power are not like terms, so I can't combine anything. There's our final answer. Okay, next one's very similar. So I have 4n squared times 8n plus 5. I need to distribute and combine any like terms if I have them. So I need to take that 4n squared, multiply it to the 8n first. Well, 4 times 8 is 32. N squared times n makes n to the third power. When you multiply like bases, you add those exponents. There's technically a 1 right there on that n inside of the parentheses. Then we take that 4n squared and we got to multiply it to that positive 5. Well, 4n squared times positive 5 makes positive 20n squared. And n squared and n to the third are not like terms, so that's our final answer. All right, next problem. All right, so now we have two binomials multiplying together. Because I see two parentheses next to each other, that means we're multiplying. Now, I need to multiply this out, and there's two methods. There's a FOIL method, or you can look at this in terms of distributing twice. The way that I'm going to do in this video is I'm going to start with this first term, 8n, and I'm going to distribute it to what's inside of the second parentheses. So when I distribute, I'm doing it via multiplication. So I start 8n times n makes 8n squared. And then 8n times negative 3 makes negative 24n. So I distributed the first term. Now I have to distribute the negative 2. So I got to take that negative 2, multiply it to the first part of the next parenthesis. So negative 2 times n makes negative 2n. And then I have to take the negative 2, multiply it to the second term of negative 3n, or excuse me, negative 3. So negative 2 times negative 3 makes positive 6. Now we go through and we combine our like terms. So there's no n squareds other than that 8n squared. So I have 8n squareds. And then negative 24n minus 2n makes negative 26n's. And then we can bring down the 6. And this is our final answer. All right, next problem. We have 4a plus 1 squared. And I want to fully expand this. Here's the thing to keep in mind about the square. So if I have something raised to the second power, that's technically telling me that what the exponent is applied to in this case means that that's how many times that is multiplying to itself. So that 4a plus 1 is technically multiplying to itself twice. And so I would rewrite it as 4a plus 1 times 4a plus 1, and then we would do what we just did, and we would distribute twice. So I'm going to take that 4a, multiply it to that 4a in the second set of parentheses. 4 times 4 is 16. A times a is a to the second power. And then 4a times 1 gives me plus 4a. And then we do it again. So I need to take the 1, multiply it to both terms in that second set of parentheses. So that'd be plus 4a. And then 1 times 1 gives me positive 1. Then we go and combine like terms. So there's nothing to put the a squareds with, so I just have 16a squareds. Positive 4a and positive 4a give me 8a. And then I have that 1 on the end, so plus 1. There's our expanded form for our answer. Okay, next one. We have a binomial, so 2 terms, times a trinomial, 3 terms. Now the process here is no different than what we just did, is we just have a few more terms to work with. We're still multiplying because there's no operation symbol in between the two parentheses here, and so back-to-back parentheses means multiply. You're going to start with the first term, and I'm going to multiply it to every single term in that next parenthesis. So 2r times r squared is going to give me, well, that's technically an r to the 1. So r to the 1 times r to the second power makes r to the third. So I have 2r to the third. And then 2r times 8r is positive 16r squared. And then 2r times 4 is positive 8r. So I distributed the 2r. Now you have to distribute the minus 2 to everything. And so negative 2 times r squared makes negative 2r squared. And then negative 2 times 8r makes negative 16r. Negative 2 times positive 4 makes negative 8. So now that you're here, combine your like terms. Well, I only have 2r to the third, so there's nothing to combine it with. My next biggest exponent is r squared. There's 16. There's negative 2r squared. Combine those, we get positive 14r squareds. Then we work our way to the just plain old r's, or r to the 1 powers. I got positive 8, and then I got negative 16. Combine 8r and negative 16r, we have negative 8r's. And then lastly, we got that minus 8 on the end. Nothing else is considered a like term. There's our final answer after multiplying. All right, and now we got this last one here. So I want to multiply, and this time we have a trinomial times another trinomial. So I have to multiply out 3 different times here. We're going to start with the first term, 3n squared, and I got to multiply it to everything on that inside of the second set of parentheses. So 3n squared times 7n squared, well, 3 times 7 is 21. N squared times n squared makes n to the 4th. And then I take and go 3n squared times 6n. 3 times 6 makes positive 18. N squared times n makes n to the 3rd. And then we have 3n squared times negative 2. Well, 3 times negative 2 is negative 6, so I got negative 6n squared. So we distributed the 3n squared. Now we do it again. We got to do the same thing with the 8n. So 8n times 7n squared. 8 times 7, negative 56. So we have negative 56. N times n squared makes n to the 3rd. Negative 8n times 6n. Positive times a negative makes a negative. 8 times 6 is 48. N times n makes n squared. Negative 8n times negative 2. Negative 8 times negative 2 makes positive 16n. And then lastly, we have to distribute the negative 2. Negative 2 times 7n squared. I'm going to have to zoom out so I get a little bit of room. Makes negative 14n squared. Negative 2 times positive 6n. Positive times a negative makes a negative, so we have negative 12n. Negative 2 times negative 2 makes positive 4. So there was a lot to multiply out there. Now we look to combine our like terms. Well, I have 21n to the 4th with nothing to combine it with, so we have 21n to the 4th. We're going to go look at our n to the thirds. I have 18. I have negative 56. There's nothing else to combine with. That leaves us with negative 38n to the thirds. Now we're looking at our n squareds. I have negative 6. We have negative 48. And we have negative 14 to put together. That gives us negative 68 n squareds. And then we're almost there. We have 16n and negative 12n to combine. You got to include the signs in front of them. So I combine 16 and negative 12. That leaves me with positive 4n's. And then we have that plus 4 on the very end there. There is our answer after we multiply together those two trinomials. All right, sometimes you might see a problem that wants you to write a quadratic expression in standard form. Well, just keep this in mind. Standard form is if I multiply something all the way out, I write it in terms with the largest exponent of x first, and then as I work my way to the right, the exponent size of x keeps going down until I get to a whole number. That's all that means in terms of a quadratic expression being written in standard form. Now, we'll come back to this a little bit later down the road. However, these next two problems simply want us to write these quadratic expressions standard form, which basically means multiply it all the way out, just like what we were doing. So, looking at this problem, we have negative 2 times x plus 5 times x minus 6. So, let's start by taking the negative 2 and multiplying it in to that first set of parentheses. And so we do that, we'd have y equals. Now, because I still have that negative, that x minus 6 there, I'm going to put that negative 2 inside the parentheses now. So I'd make negative 2x minus 10. And then we still have the times 6 minus x. So we multiplied the first part. Now we have to come in, and now we have to distribute again. So that way I can get everything out of parentheses. So I'm going to multiply that negative 2x to that x in the other parentheses, which is going to give me negative 2x squared. And then I'm going to take the negative 2x, multiply it to the negative 6. That's going to give me positive 12x. And now we work our way. We're going to multiply that negative 10 to everything in that other set of parentheses. So negative 10 times 1x makes negative 10x. And then negative 10 times negative 6. Two negatives multiply to make a positive, so I got plus 60. Now, to put in standard form, biggest exponent comes first, and we combine all of our like terms. Well, there's only one of those x to the squared, and that's a negative 2x squared, so I'm going to write negative 2x squared. I have 12x and negative 10x that I can combine, so 12 combined with negative 10 leaves me with positive 2x's, and then we have plus 60 on the end. There's nothing else I can put together because they're not alike. There's our final answer, and it's written in that standard form they were talking about, biggest exponent of x written first. Okay, next one here, I want to write it in standard form also. I need to multiply this thing all the way out. Well, in this particular case, I cannot take that negative 5 and multiply it inside the parentheses because the parentheses has the exponent. So we have to follow PEMDAS, or order of operations. So I got to start by multiplying this thing out here, or at least rewriting it a little bit differently. And so what I'm going to do is I'm just going to rewrite this differently. I'm going to rewrite this as negative 5 times. Well, x minus 2 to the second power is the same thing as x minus 2 times x minus 2. And then I still have this minus 7 on the end. Now that I've rewritten it, I can treat it like the problem that we just did before. Or if I wanted, I could take this negative 5, multiply it into the very first set of parentheses, and then rewrite. So if I do that, multiply the negative 5 inside of the first set of parentheses, we'd have negative 5x plus 10 times x minus 2. And then I still got minus 7 here on the end. And now we're ready to multiply this thing all the way out. So we're going to take that negative 5x, multiply it to both terms on the inside of the second set of parentheses. Negative 5x times x makes negative 5x to the second power. Negative 5x times negative 2. Two negatives multiply to make a positive, so that gives me positive 10x's. Now we go to that next term of 10. It's got to multiply to everything inside that next set of parentheses. 10 times x makes plus 10x. And then we'd have 10 times negative 2, which makes negative 20. And we still got minus 7 here on the end. Now our final answer, we combine all of our like terms. So we do that, we'd have negative 5x squared. I can put together 10x, and 10x makes 20x. And then negative 20 and a negative 7 combined make negative 27. And there is that quadratic written in standard form. All I had to do is multiply it all the way out.